Welcome back. In this video, we are going to continue our work on understanding and learning more of the language of mathematics. Much of the vocabulary in this section we will use throughout the year, and so if you want to know what we're talking about in future videos and future lessons, you will need to be familiar with and comfortable with much of the vocabulary that we will see here in this particular section. So in this section, we're going to work on symbols, number sets, and do a little bit of introduction to fractions. So let us begin. A set. A set is simply a collection of objects, usually numbers in mathematics. And an element is any member of a set. So here's an example of set A that is made up of the elements -1, 0, 1, 2, and 3. There's an infinite number of different kinds of sets that we'll see, but you just need to understand, the element of the items that are included in the set. We'll work quite a bit, of course, with our number line. The number line is comprised of the set of all real numbers. In fact, a real number is any number that can be found on the number line. Okay, so our number line, of course, includes 0. Our positive numbers are all to the right of 0. Our negative numbers are all to the left of 0. And it includes your whole numbers, your integers, your fractions, rational numbers, irrational numbers. All those numbers are on the number line. So numbers like pi or the square root of 5, they're all on the number line somewhere, and they have just as much right to the number line as numbers like 1 and 2 and -1 and -2 and so on. Continuing on with our definitions, I've already talked about real numbers. Real numbers are kind of the parent of our number system that we're going to be working with. Any number on the number line is a real number. And then we do subcategories of those real numbers. Rational numbers are a subcategory of real numbers. They're simply a quotient of any two integers. So numbers like the fraction 11/3 or 5/2 or even an integer 12/1 or simply 12 as we usually look at it. 0 or 0/1. Gotta love mathematicians. Irrational numbers are numbers that are not rational. So anything that can't be expressed as a quotient of two integers is not rational. And that includes numbers like pi or the square root of 2 or the square root of 5. Those numbers, etc., would be considered irrational. Integers. For our purposes, an integer is going to be a rational number in which the denominator, the bottom of the fraction, is 1. It's in simplified form. So our integers are going to be the set, like -2, -1, 0, 1, 2, and so on. Okay? So those would be our integers. Our whole numbers are the positive integers plus 0. Okay, so the positive integers, because 0 isn't either positive or negative, so positive integers are numbers like 1, 2, 3. Okay, so our whole numbers would be the set 0, 1, 2, 3, 4, and so on. Whereas these numbers here, those are going to be our positive integers. And of course, our negative integers, that's pretty obvious. That's going to be the set, like -1, -2, -3, and so on in the negative direction. Natural numbers, counting numbers, positive integers, those are all the same thing. I've already talked about that. Those are the whole numbers without 0, or our positive integers. So if you hear us talk about natural numbers or counting numbers, those are the numbers we're talking about. Absolute value. absolute value, when you see or hear absolute value, I know we always think, oh, absolute value is always positive. That's true. But when we see absolute value, I want you to think distance. Absolute value is the distance between a real number and some origin, usually 0, on the number line. So we want to think distance from an origin or distance from 0. Distance can be both to the right in the positive direction and left in the negative direction. But distance, the distance covered, is still positive. So thus, since any distance is either positive or 0, it's never going to be negative. And of course, the absolute value, you'll see the absolute value bar. So the absolute value of -4, if we take the absolute value, is 4. Okay? A little bit more vocabulary. Fraction is a quotient of two numbers, two integers. The numerator, of course, is the top of the fraction, and the denominator is the bottom. So something to keep in mind, the denominator of a fraction cannot be 0. Okay, that is a number that's undefined. So if our fraction, we could have a fraction of 1/2, we could have a fraction of 5/4, okay? I've already used like 11/3, and I don't look at 5/4 and 11/3. I don't see those as improper fractions. I mean, technically, that's what they're called. But my preference will be to use the improper fraction. We'll stay away from mixed numbers. Very rarely will we use a mixed number. The exception might be in a word problem where there's some context to the answer, and having 1 1/4 makes a little more sense than 5/4. But oftentimes we'll just use the most simplified version of the fraction, but not a mixed number. Another thing with fractions, the sooner you learn this and realize it, the better your math career is going to be. A fraction, 0 over a number, is 0. 0 over any number is 0. Whereas some number over 0 is undefined. So we don't want 0 in the denominator. If 0 is underneath, so 0 is underneath, we are working with a number that is undefined, underneath undefined. Factors. Factors are simply numbers that are multiplied. Okay, so any 2, 3, 4 things that we multiply are factors. So 2 times 4 times 16, these are all factors. Whereas if we add things, those are going to be terms, and that's something different. So factors are numbers that are multiplied, and the product is the result of multiplying those factors. Okay, so whatever 8 times 16 is some product. We'll make 16 10 for me, and that is 80. Okay. A simplified fraction in lowest terms is when the numerator and denominator have no common factors other than 1. And I will expect you to simplify your fractions and put them in lowest terms. So the fraction 6/4, well, that's the same as 3 times 2 over 2 times 2. And 2 over 2, we know that's 1, so that simplifies to 1. So that makes that 3/2 times 1, or 3/2. So now that is simplified. A prime number is any natural number other than 1 whose factors are only 1 and itself. So a prime number, its only factors are 1 and itself. A prime factorization, we'll be doing factorization, and we can rewrite a number as a product of its prime factors. So 36, clearly a number that's not prime. 6 times 6, 9 times 4, 12 times 3, lots of factors of 36. If I did a prime factorization of 36, I might use 9 times 4. Neither of those are prime, but 9, I could rewrite that as 3 times 3, and 4 is 2 times 2. And if you remember exponents, you would know that that would be 3 squared times 2 squared. But either one of those would be acceptable right now for a prime factorization. So you could do a prime factorization of 40, do that factoring tree, and I'll let you do that and bring that to class. A reciprocal. Reciprocals are two fractions whose product equals 1. They are reciprocals. So essentially, we flip the numerator and the denominator of any rational number. So a reciprocal would be, well, what's one of my favorites is 3/5. The reciprocal of 3/5 is 5/3. Down below here, I have some notes about multiplying fractions. So product here is multiply. If we multiply our numerators, 3 times 5 is 15, and 5 times 3 is 15. We get 15 over 15, which is 1. So those are reciprocals. Okay? So the tricky ones are integers. So the reciprocal of 2 is 1/2. We have to remember this is really 2 over 1, isn't it? So when we flip it, it becomes 1/2. So as I alluded to, when we multiply fractions, we just multiply the numerators and multiply the denominators. That's pretty straightforward for us. It's easier than adding or subtracting fractions. We just multiply across. So in the textbook, we might have something like A over B times C over D. We just multiply across. That's equal to A times C over B times D. Something like 2/7 times 3/10 is equal to 2 times 3 is 6 over 42. Oh, where am I getting 42 from? 2 times 3 is 6. 7 times 10 is 70. So, and 6 and 70 are still even, so we must have a common factor there. So we could have probably cross-canceled here, done 1 over 5. And sure enough, that's the same as 3 over 35, and that's simplified. Dividing fractions. When we divide fractions, division by definition is multiplication by the reciprocal. So multiplication, division is multiplication. But we multiply by the reciprocal of the fraction to the right of the division symbol. So if you can divide fractions, you got to be able to multiply fractions. So we might have something like 3/4 divided by 5/7, which is the equivalent of 3/4 times 7/5. So we're dividing by 5/7, and we get 3 times 7 is 21 over 20. Adding and subtracting fractions, a little bit more challenging. When we add and subtract fractions, we add only the numerators, but we must have a common denominator. So we leave the denominator, once we have a common denominator, we leave it alone and don't do anything. So a simple one, like 2/11 plus 5/11 equals 7/11. So we have our common denominator here. So we leave the denominator alone. Different than multiplying or dividing, where we multiply here, but we don't add these denominators. So we get 7/11. Adding and subtracting fractions with different denominators, well, we need to write one of the fractions or both as an equivalent fraction to have a common denominator. So for example, if I tried to take 3/8 and add it to 1/20, now this one, we don't have a common denominator here. And our common denominator you might see is 40. 8 times 5 is 40, 20 times 2 is 40. So I would multiply the 3/8 by 5 over 5, that's 1, and the 20 by 2 over 2, so I don't change my value on the number line, and I get 15 over 40, it's the equivalent of 3/8, plus 2 over 40, it's the equivalent of 1/20th, but now I have a common denominator, and I get 17/40ths, and there's my answer. So I'm going to have you bring to class, what's 19/6 minus 23/12? Once again, we don't have a common denominator, but get a common denominator, show your work, and bring that to class. So that wraps up this section of vocabulary, some work with fractions, adding, subtracting, multiplying, and dividing, and bring those sample problems, and we will see you in class.